everyone. In today's lesson, we're going to talk about how to graph rational functions by hand. Some with holes, some without, some with slant asymptotes, some with horizontal asymptotes, pretty much all of the above type deal. We're actually going to save problem number 1 for tomorrow's lesson, and I'd actually like everyone to jump to problem number 2 on the back. Okay, so we have to graph this thing. So we need to figure out a couple of items. So the first thing that we want to find is any potential holes and vertical asymptotes. So what we're going to do is step 1, we're going to factor. And we're going to try to simplify this expression. So if you look, the top, the x minus 2, I really can't factor that. So I'm just going to rewrite it as x minus 2. But the bottom is a trinomial that I can definitely factor. What are the factors that add to 1 that multiply to negative 6? So here you should be thinking x plus 3 and x minus 2. So what you see is that these x minus 2's are the same, so they get to cancel. So what that tells us is that we have a hole at the opposite sign. So we have a hole at x equals 2. So we actually want to rewrite this, though, as one simplified equation. So anything divided by itself is 1, so don't forget that 1 on top. So we have 1 over x plus 3. That's my new simplified equation. So since we know we have a hole at the opposite sign, right, if the factor is x minus 2, the hole will be at x plus 2. If we want to find the y value of the hole, we're going to simply plug this 2 into this simplified equation. So let's go ahead and do that. So we've got 1 over 2 plus 3, and that gives me 1 over 5, 1/5. So my hole is x equals 2 and y equals 1/5. So we found our hole. Now, once we factored and we found our hole, any leftover denominators become our vertical asymptotes. So my second step is to write down what my vertical asymptote is. So here, my vertical asymptote is the opposite value. So if x plus 3 is my leftover denominator, I simply set that equal to 0 and solve. So my vertical asymptote is x equals negative 3. Now the next thing that we want to try to figure out is, do we have any horizontal asymptotes and or slant asymptotes? So remember, horizontal asymptotes, we look at the original function and we're looking at the degree of the numerator and the degree of the denominator. So if you look here, the degree of the numerator is 1 and the degree of the denominator is 2. So the degree of the numerator, n, is less than the degree of the denominator. And when that's the case, the horizontal asymptote is nothing other than the line y equals 0. And if we have a horizontal asymptote, then we do not have any slant. So there's no slant asymptotes here. And the last other pieces that we'll need to graph this thing are x and y intercepts. So step 5 will say our x and y intercepts. So remember, to find an x-intercept, we are going to set y equal to 0. And to find a y-intercept, we're going to set x equal to 0. Now, which equation do we use? We use the simplified equation. Okay. If you want to even write down the horizontal asymptote, we use the original equation. Okay, so for the simplified equation, we're going to go, and it's this guy right here, 1 over x plus 3. So we can actually just rewrite that first. So we have f of x equals 1 over x plus 3. And we're setting y, or f of x, equal to 0. And we put this over 1 and cross multiply. 1 times 1 is 1. 1 times 0 is 0. So that doesn't make any sense. Therefore, we will have no x-intercepts. Okay, let's use that same equation to find our y-intercepts. So for the y-intercept, we're going to set x equal to 0. and solve. So 1 over 0 plus 3 is 3. So 1/3 is my y value. Now remember, x and y intercepts are expressed as points. So the x value is 0 and the y value is 1/3. And that is my y-intercept. So let's see if we can answer some of the parts that I had asked you to find. So I asked you to find the domain. Well, if we go back up to the top here, the domain would simply be all the values except for the undefined values. So my undefined values are my holes and my vertical asymptotes. So I have a hole at 2 and I have a vertical asymptote at -3. So we will say the domain is going to be all real numbers. So I like to use this symbol for all real numbers except for when x is equal to 2 and when x is equal to -3. So if you want to write some notes down, the domain will be all real numbers except for the holes and vertical asymptotes. So then that leads me to my next point. It says here, find the vertical asymptotes. Well, we did that. We got x equals -3. We found the hole. That was 2, 1/5. We found our horizontal asymptote, which was the line y equals 0. And we know if there's a horizontal, then there is no slant, so we can put none. We found, as we scroll down here, we can see that there are no x-intercepts. And our y-intercept we found was the point 0, 1/3. Now, to find the range of this graph, it's actually easier if we use our picture. So now it's time to graph with the information that we have. So let's go ahead and plot our vertical and horizontal asymptotes. Those are generally the easiest ones to start with. So vertical asymptote of x equals -3. So I'm going to go ahead and always label my vertical asymptotes as dotted, right? Anytime we have an asymptote, it's very important that we write it as a dotted line. So x equals -3. And our horizontal asymptote is the line y equals 0, which happens to be the x-axis. So again, I'm just going to write over it with a dotted line and label that with the line y equals 0. I have a hole at 2, 1/5. So we're just going to draw a little bit of a sketch here. So 2 and then 1/5 would be somewhere around there, right? Over 2, up 1/5. And it looks like we have a y-intercept of 0, 1/3. So I'm going to go ahead and plot that point. So we have the point 0, and then 1/3 would probably be somewhere around here. So we actually can use these asymptotes as kind of boundaries. And we know that rational functions have these branches that I spoke about in class. So we can actually use these two branches here and just say, well, my rational function is probably going to do something like this, right? It's got to contain those two the hole and the y-intercept. So it's fair enough we can draw a little bit of a sketch through there. Now, technically, this graph, the other branch, could be here, or the other branch could be here. We don't know where it is. The branch can't be here. And the reason why is because let's just pretend it was there. If the branch were here, then this graph would actually fail the vertical line test, so it wouldn't be a rational function anymore. So it can only be here or here, right? It would fail the vertical line test in that spot. So I'm going to go ahead and erase that from here because that's not where it is. So since we don't have enough information, we don't know if it's going to be here or here. So this is where we may need an additional point. So we want to figure out where the graph is over here. So let's say -1, -2, -3, maybe -4, -5, -6. You could use any number you want. I'm going to choose -4. And I'm going to see if it's above the x-axis or below the x-axis. So let's go down here and just write down additional points. And my idea is going to be to see where the graph is at x equals 4, negative 4. You could say negative 5, negative 6, negative 10. Doesn't matter where. And you can use the simplified equation. So f of x equals 1 over x plus 3. So 1 over negative 4 plus 3 is 1 over negative 1. Negative 4 plus 3 is negative 1. And I get y equals negative 1. So the point would be negative 4, negative 1. So basically what you just solved for by testing out negative 4 is where the graph would fall here or here. So we can plot that point. So the point would be negative 4, negative 1. So since the point's there, we know that the branch is going to do something like that. And that's enough information for me to graph this rational function. All right, now the last piece is to find the range. So remember, range is how tall the graph is and how low the graph is. So you see here the graph is at negative infinity, goes all the way up, all the way up. We see graph, still we see graph. But notice this horizontal value at 0 shows us that we don't have a graph at the line y equals 0. So the range for y equals 0 is out. And then let's look up here. So I've got all these values, but even this guy, notice how there's a missing y value there. So we actually have to account for them. So when we're writing the range is going to be similar to the domain, that it will be all real numbers except y values of wholes and any horizontal asymptotes. So up here, we said the domain was all real numbers except for wholes. Maybe we should say x values of wholes, except x values of wholes and vertical asymptotes. So for the range, it'll be all real numbers except y values of wholes and horizontal asymptotes. So my range is all real numbers except for when y is equal to 0, which is the horizontal asymptote, and y is equal to 1/5, which happens to be this y value of the whole. So that's it. Those are all of the pieces to graph this rational function. So take a couple minutes and jot down any questions that you might have, and make sure you ask us in class tomorrow. Okay, have a great night.